Welcome back, everybody. Okay, so now everything's kind of back to normal. We will now go and continue on with the Blender 3D Noob 2 Pro book. Okay, types of textures. When you create a texture in Blender, you'll see a pop-up menu listing a whole lot of different types for the texture. The image or movie texture type lets you use a scan image or texture to texture your object. For example, you could scan an actual piece of metal and use that to give your object a realistic metallic appearance, or use a photograph of an actual brick wall texture to texture the wall of a building model, and so on. Or you could even use a movie which plays during the animation of the scene. The other texture types are called procedural, which means the textures are generated according to algorithms built into Blender itself. These can be used for simulating various effects when you don't have an image of the real material handy. They can also be applied to augment the appearance in various ways, for example, using a cloud texture to dirty up a material, or using one texture as a stencil to create an amalgam of two other textures. Cool. Okay, so let's go to the next, which is Noob to Pro Quickie Material. Okay, we're gonna see if we can do this in this Blender here. So what I'm gonna do here is I'm gonna actually do a new, and I'm gonna do whoop, here. Okay, new, general, that. Okay, cool. And then your first material. Okay, in this module, you'll create a new material called green ooze, and along the way, you'll learn how to alter the diffuse specular mirror colors of the material. We'll see. This might be a little bit different, so I don't know. The cube in the default scene has a simple gray color. Click on the materials in the properties window. I wish that they would go back to the really nice images that they use for the icons, because they're much better than it is right now. Materials contains various menus, but for now you'll need to diffuse specular mirror. The material is named and linked in the panel above the preview window. Linking is a feature allows materials to be shared between multiple objects or data blocks. Changing materials affects the appearance of everything is linked to. The first row of the window above the preview indicates that there is one material assigned to this object. Its name is material. Second row indicates that the currently selected material's name is material. This material will only be saved if it's in use. It is not a node's material. Instead of being linked directly to an object, the current material is linked to a data block. And I don't think that's the same now, because right now it's actually looks like it's using nodes. What if I said not use nodes? Right? Diffuse specular shading. Let's see, what do we got here? Specular, roughness, metallic. What do we got there? I'm just looking at my screen. That's why my hat's going off here, getting cut off here. Ambient, translucent, surface. Interesting. Okay. Rename the material. Click on the name. To unlink the material. Do this now. Deletes the link to the data block. Remove the material from the mesh. As a side effect, most of the panels of the material context disappear. You'll see in a moment. However, the material still exists. It hasn't been deleted. It's simply no longer used. Okay. To rename the. Okay. Let's call it green ooze or something. Okay, and then click on the X. Okay. Material name. This deletes the link to the data block, removing the material from the mesh. As a side effect, most of the panels in the material context disappear. You will see in a moment, however, that the material still exists. It hasn't been deleted. Right. Simply no longer in use. So it looks like my dry run today didn't work out too well. Okay. At this point, you could click the new button to create a new material, but instead we're going to reapply the old material. Click on the button to the left of the new button. You'll see the nifty drop-down list. Choose 0 material. I did change the name, but I'll choose it. Materials whose name are preceded by 0 in this list are not in use. By default, Blender doesn't have such materials when it saves a scene. Thus, you can delete a material from the list by saving the scene and then reopening it. You can override this behavior by tackling the F button on for unused materials you want saved. Materials would be much easier to find and manage if you give them brief descriptive names you can recognize at a glance. Change this one's name to green O's. In addition, naming your materials and other stuff in the scene will enable you to choose the right objects. Materials, okay. Example, you're working on a new Blender project, but the material you use in the Blender is worth it. Instead of going through the pain of creating new material, of course you guessed it, initial, okay. You just append the material to your new work. Pretty simple. Make naming it happen. Okay. I'm not going to worry about that right now. Simple materials are specified for 3 colors: diffuse, specular, mirror. Rectangular patches, swatches of color in their own panel. In the material context, allow you to see and changes to these. Diffuse colors the basic underlying color, rendered by the diffuse shader. Specular colors for highlights. Rendered specular shader mirrors for true reflections, rendered using ray tracing. There are many ways to define colors. The Blender supports 3 RGB. Red, green, and blue primary colors, 0.0 to 1.0 for each component. For example, RGB 000 specifies black. The color all 010 is full green, 110 is full red plus full green is yellow. 0.5, 0.5, 0.5 is 50% gray, and 111 is full white. Maximum intensity on all components. Note, this is additive mixing colors, which happens when you shine lights of different colors onto a white screen. Not the subtractive mixing that places when you mix different colored paints or inks on paper or canvas. Obviously. In other words, red and green would actually make brown on subtractive mixing. By specifying a hue, color position on the rainbow, together with the saturation, strength of a color from garish to down to pastel with 0 giving shades of gray, and value brightness. This is generally considered to be easier than using RGB notation when you're trying to create new colors, as opposed to copying a color spec from somewhere else. Since it's easier to predict what the likely result would be, HSV is commonly represented on the color wheel, where the hue is the angle around the circle. Saturation, the distance from the center, and value controlled by a separate brightness slider shown below. By specifying a 6-digit hexadecimal number, this is just an alternative form of RGB notation, commonly used for color specifications web pages. If you click on any color swatch, the color picker will pop up, allowing you to change the values. This is the most intuitive way. The window appears will look like this and will include the following. Color wheel, change the color as you want. In HSV mode, H responds to the angle around this wheel, S distance from the center. 3 color sliders will change if you change the color of the color wheel. You can also change the values of sliders. The slider that controls the intensity of the color corresponds to the V in HSV. A pipette capable of sampling colors from any Blender window or render window. Buttons that can change it to HSV or HEX mode. HEX meaning hex. Alternatively, you can specify hue, saturation, and value components by clicking LMB on the HSV button, pushing the sliders around accordingly. You can also press the last button to enter a hexadecimal or hex code. HSV is probably the most easily understandable. This is why Wave's experimenting with colors. However, as is common in most computer systems, all colors from Blender are represented internally as RGB. If you want to get rid of a window, just click LMB anywhere else. Okay. Duplicate intensity sliders. There are 2 ways to control intensity of the color. There's the vertical intensity slider at the right and the color picker pop-up. There are also intensity fields at the bottom of of the diffused specular panels, the intensity being the combination of both values. Why two different rays? Partly because this is a quick way to moderate intensity of the diffuser specular components without having to change the actual color specification. More importantly, this is to ensure the intensities are never set to 100%. The reason is that this can cause rendering calculation problems, leading to a total of 8 intensities, accumulating to infinity instead of merging into a finite value. It's probably not a big issue with the Blender internal renderer, but can become a problem with the more advanced renderers. Okay, so now, really I'm at the end of this video, and so just to kind of show where it's showing it, HSV, right, hue, saturation, and value. So hue can change whatever. Okay, so let's do saturation. See where it went down to like red, the most saturated. Hue will actually change its actual color. Darn it. And of course value is like your brightness, so down all the way to there, right? And then of course the alpha is just kind of your transparency, how transparent you are. Okay, and then so then your metallic is how shiny it is, I think. Specular. It has something to do with here. Let's see something here. Let's do this. Can we see that there? More metallic it becomes more, and then of course your roughness. Anyways, it's not rough, it's smooth and shiny, if you notice kind of here. Base color, let's turn the vibe. Oh, let's do something like this. Okay. Less metallic, more metallic. More metallic seems to make it like really dark. I'm not sure why, but specular, roughness. Anyways, that's it. I will see you later. We'll try to recreate the material in the tutorial when I get to it the next time. So thanks for watching, and I'll talk to you on the flip side.